Okay, so in this video here, we're going to be talking about how to factor higher degree polynomials. So the first thing that we have to do here is try to factor this polynomial, and you can see that I'm dealing with a cubic. Now, typically when you factor, you're going to be dealing with a quadratic. Now, notice here that I have four terms. I have one term here, here, and here. Whenever you have a polynomial and you have four terms, there's a possibility that you could factor by grouping. And that means you just group together the first two terms. So I'm going to go ahead and group these two together, and then I would group these two together and see if I can pull out a greatest common factor. And then I would check to see if I have a common factor. If I do in fact have a common factor, I could go ahead and do this problem by factor by grouping. But that's not going to work out here. Okay, I'm not going to get a common factor. So how do you factor it? Well, you have to use the rational root theorem. You have to come up with possible rational roots of this polynomial. So for example, we know that the rational root theorem is when we take the factors of our constant, in this case here, -1, and we put it over the factors of our leading coefficient, which in this case here is going to be +5. So I'm going to do that by making a list. So factors of my constant are going to be ±1 all over, and then factors of my leading coefficient, that's going to be ±1 and ±5. So +1, and then ±5, okay? And then I just have to divide these out. So doing 1 divided by 1, I get ±1, and then 1 divided by 5, I get ±1/5. So these are possible rational zeros of this polynomial. Now my recommendation to you, take out your graphing calculator and go ahead and plug in this polynomial right here so you can see where it's going to be crossing the x-axis. Because if you don't do that and you don't know where it's crossing the x-axis, you're going to have to guess and check on these zeros that you just came up with. Now, you may get lucky and you may pick one that works right in the beginning, but you may not get lucky and you may be testing these until you find one that works. So how do you know if it works and how do you know if it doesn't work? Well, you have to do synthetic division. When you do synthetic division and you test these zeros here, if you get a remainder of 0, that tells you that that rational zero that you came up with is in fact going to be a zero of that polynomial, meaning it's going to be a factor of that polynomial. So for example, let me show you. We're going to go ahead and set up synthetic division. So doing our synthetic division bar, we're going to list out our coefficients, 5, -11, +7, and then -1. I don't skip any powers, so I don't have to put in any zeros. Now, I already have this graph pulled up on my graphing calculator. I know where this polynomial is crossing the x-axis, but I just want to show you what would happen if you pick one of these possible rational zeros that you came up with, and it's not, in fact, a zero of this polynomial. So, for example, I'm going to do -1/5. If I pick -1/5, what happens? Well, I bring down my 5, and then I multiply. The 5s will cancel. I'll get -1. When I add here, I get -12. And then when I multiply here, I get 12 over 5. So I have to write 12 over 5 here. You're going to add these up, and you're going to see that your remainder that you end up with is not going to be 0. Meaning, if your remainder is not going to be 0, this value right here that you just tested is not going to be a 0 of this polynomial up here. Okay? So -1/5 is not going to work because we're not going to end with a remainder of 0. So again, assuming you plug this into your graphing calculator, I can see that it's crossing the x-axis at 1 and also 1/5. So +1/5. So I'm going to go ahead and use +1/5 here instead of -1/5. So I'm going to go ahead and get rid of this stuff here. And changing it to a +1/5, what happens? So we bring down our 5 and then we multiply. We end up with 1 here, okay? Because the 5s will cancel. -11 plus 1, we get -10. -10 times 1/5, that's going to give us -2. 7 plus a -2, that's +5. 5 times 1/5 is 1. So you can see here my remainder is in fact going to be 0, meaning this 1/5 is going to be a 0 of this polynomial. And actually, we can put it in its factored form right now because it's actually x equals 1/5. So in its factored form, it's actually going to be x -1/5, okay, in parentheses like that, okay? So that would be the factored form, and I'm going to leave that there because we're going to need that later because they want us to factor this thing out. So I'm going to end up using this factor right here when we end up writing the complete factorization of this polynomial. So what you have here is a quadratic now. I have x squared I have x, I have my constant, and then my remainder. I have to try to factor it. So if I have 5x squared minus 10x plus 5, it's now my job to try and factor that quadratic. And can you factor it? Well, yes, you can. You could also use the quadratic formula if you wanted to, but always look for the path of least resistance. I can actually pull out a 5 between all of these terms. If I pull out a 5, I'm left with x squared minus 2x plus 1. Now factoring this quadratic here is pretty easy. And to do that, you would just do the AC method. If I do the AC method, a times c, that's 1, right? I have a 1 here in front of my x squared. So I need two numbers when I multiply that will give me 1, but add up to -2. Well, that's going to be -1 and -1. When I multiply them, +1. When I add them, -2. And since my a value here is equal to 1, I can go ahead and put this right in factored form. So putting it in factored form, you're going to have x minus 1, x minus 1, and then again, you do have that 5 that you factored out at the beginning right here. So we're going to include that 5 right here. And then you're ready to write the complete factorization. Remember, we do have this factor up here that we underlined so we wouldn't forget. So I have to include that factor somewhere in the problem. I'm just going to put it right on the end. I have x minus 1/5. Okay, there it is. There's the complete factorization of that polynomial. And again, we did that by using the rational root theorem and then using synthetic division. Okay, let's try one more problem. And so here's our last problem, and notice how you have 4 terms here. So whenever I see 4 terms on a polynomial and they're asking me to factor, I always try to factor by grouping. So I try to group together the first 2 terms and then the last 2 terms, see if I can pull out a greatest common factor, and then see if I will end up with a common factor. Now, in this problem here, it's not going to work out. Like if I use my first 2 terms here, I can pull out a x cubed, okay? That will leave me with 3x and then plus 7, okay? Looking at my last 2 terms, I can pull out an x, so plus x, and that leaves me with 5x plus 1. So you can see these factors right here, they're not common, they're not the same, meaning we cannot factor by grouping here. It's not going to work out. So we can't do that method. So let's go ahead and get rid of this stuff here. We have to go ahead and use the rational root theorem and do exactly what we did on the other problem. So using the rational root theorem, we have to come up with factors of our constant over factors of our leading coefficient. Now this one's a little bit different because you do not actually have a constant here. So how could you get around that? Well, notice all 4 terms here. They have something in common. They have an x. I can pull out an x between all 4 of these terms, and then I will have a constant that I can work on. So if I pull out an x, I'm left with 3x cubed plus 7x squared plus 5x and then plus 1. Okay? Now, be careful here. When we write the complete factorization, we have to make sure we include this x. Okay? So as of right now, this x is just going to come along for the ride, okay? What I'm going to be working on now is this whole part in here, okay? I'm going to work on factoring that part, okay? So don't worry about the x right now. We'll worry about that later. So now I have a constant. So factors of my constant are going to be plus or minus 1 all over factors of my leading coefficient. So again, my leading coefficient here is 3. So that's going to be plus or minus 1 and plus or minus 3. And then we just have to divide it out. So 1 divided by 1, we get plus or minus 1. And then 1 divided by 3, we get plus or minus 1/3. So you have 4 possible rational zeros here. And again, plug it into your calculator. That way you do not have to guess and check. So when you plug this into your calculator, you're going to see that it's crossing the x-axis at -1/3 and -1. And I do just want to clarify, you are plugging in the one that we have underlined right now. You are not plugging in the original. So you're plugging in 3x to the 3rd power plus 7x squared plus 5x plus 1. If you plug in the original, you're going to see that you will end up with another 0. But we factored out that 0 at the beginning. That's going to be the x value that we factored out. So you want to make sure that you're plugging in the one that we have underlined right now, not the original, because if you try to use that 0 for the next step, it will not work out because technically we factored it out. And so with all of that being said, we're going to have to divide this one time using synthetic division because I technically have a degree of 3 now, not a degree of 4, because again, I factored out that x. So we're going to go ahead and do synthetic division, and then we're going to go from there. So doing synthetic division, I write out my coefficients, which are going to be 3, 7, 5, and 1, okay? And so from here, you could go ahead and pick the -1, you could pick the -1/3, it won't matter. I mean, -1 is definitely a lot easier to work with than that fraction -1/3. So I'm going to put -1 here. But again, if you pick -1/3, you should get a remainder of 0 as well, just by looking at our graph. So I'm going to pick -1 though. I'm going to bring down 3, and then I'm going to multiply, and then I'm going to add here, right? Multiply, and then add, multiply, and then add. Okay, there's my remainder of 0. So now technically this is x squared, this is x, and then my constant, so I'm left with 3x squared plus 4x plus 1. Is there an easy way to factor it? Can we pull out a greatest common factor? And we cannot here. So we're going to have to do the AC method, and we're going to have to factor by grouping. So when you do the AC method, you get 3 times 1, and that's going to give you 3. So I need two numbers when I multiply, that will give me 3, but add up to 4. Well, that's going to be 3 and 1. Now, because A is not equal to 1, we have to factor by grouping. So you're going to rewrite the problem as 3x squared, and then grab any value. It doesn't matter. I can grab the 3 or the 1. It does not matter. I'll grab the 3. So plus 3x, and then plus 1x, or just x. And then you have this plus 1 here. So you should have 4 terms when you factor by grouping. I do. I'm going to group together the first 2 and then the last 2, okay? So what can I pull out between the first 2 terms? Well, I can pull out a 3 and also an x. So I'm going to go ahead and write this up here. That way we have room. I can pull out a 3. I can also pull out an x. That leaves me with x plus 1, okay? Going on to my next 2 terms, it doesn't look like I can pull anything out, but you always want to pull something out, even if it's a 1 or a -1. So I can pull out a positive 1, and that leaves me with x plus 1. So we do have a common factor here. I have it right here and here. We're good to go, okay? So when I factor it, I'm going to write x plus 1. I write the common factor 1 time, right? And then I write 3x plus 1. Write those outside values together. And now go back to the beginning. We factored out an x here, okay? And this rational 0 that we used right here, okay, it proved to be a 0 of that polynomial, meaning it's also going to be a factor, because right now it's x equals -1. When I put that back in factored form, it's going to be x plus 1, okay? Meaning this is occurring 2 times, this x plus 1, okay? So I'm going to square it, and then again, this x right here, we're just going to go ahead and include it at the beginning or the end. It doesn't matter. I'm just going to put it right here. So notice here you have that factor x plus 1 occurring twice. So whenever you have a factor occurring more than 1 time, that means it's either going to be bouncing or passing through that particular point. So if your exponent is even, okay, it's going to be bouncing at that point. If it's odd, it's going to be crossing through that point. That tells me that this polynomial is going to be bouncing on the x-axis at -1, because again, this exponent here is even. Now, if that was to the 3rd power, it would be crossing at -1. And then if it was to the 4th power, it would be bouncing. If it was to the 5th power, it would be crossing, and so on, okay? But this right here is completely factored, all right? So that's the complete factorization of that polynomial. And so that's pretty much it. That is how you factor higher degree polynomials. You want to go ahead and try other methods before defaulting to the rational root theorem, because it is a little bit more work. But if all other methods fail, you do have to use the rational root theorem. Use your graphing calculator. That way you're not guessing and checking when you're doing synthetic division. And then bring it down to a quadratic. Once you bring it down to a quadratic, then you can go ahead and factor it. So that's going to do it for this video. I hope that you learned something from this video. I hope that you gained something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel. That way you get more math videos in the future, and I'll see you in the next one.